So in this video, we are going to learn how to name and write ionic formulas. So this is going to reinforce a little bit of what we did in the previous video. I already alluded to how to name anions, and so we're going to apply this concept more to achieve the following learning goal. Given the formula of an ionic compound, write the correct name, and given the name of an ionic compound, write the correct formula. To name an ionic compound, we give the name of the cation first, followed by the name of an anion. So first we're going to focus on binary compounds. These are compounds that contain only two elements. Because they contain only two elements, we are going to be looking at a metal and a non-metal. So, the metal is the cation, and that will come first. Then it will be followed by the name of the anion, which is the non-metal. We generally ignore subscripts in naming binary compounds. For example, aluminum with 3 chlorines would be aluminum chloride. Okay. So again, to generate the name of the anion, you are going to add "ide" to the stem part of the name. So as it says here, the name of the nonmetal is the first syllable or stem of the nonmetal name, and we are going to add "ide" to the ending. So in table 6.5, it looks at some names of ionic compounds. Again, these are all binary compounds where we have two elements, a metal and a nonmetal. So we have Ki, the metal ion is potassium, the nonmetal is iodine, but we drop the ending and add "ide." So the full name will be potassium iodide. Next we have magnesium and bromine. Magnesium forms the 2+ cation. Bromine will form a bromide anion. So we have magnesium bromide. Then we have aluminum and oxygen. Aluminum forms the aluminum cation, and oxygen forms an oxide anion. Aluminum oxide. Note with these second and third examples, we do not worry about the subscripts when we are naming. So we ignore the subscripts when naming binary compounds. So let's do a learning check. Name the following ionic compound based upon the formula given. Pause your video and write down the name. So we have potassium, which is our metal, and oxygen, which is our nonmetal. So the cation formed will be K+, and the anion formed will be oxide. So that when we put the following two together, we get potassium oxide. So now let's name the following ionic compounds. Pause your video and write down the names. So the first one, we have calcium and oxygen. So we will form calcium oxide. Then we have aluminum and sulfur, and this will be aluminum sulfide. And then finally we have magnesium and chlorine, which will form magnesium chloride. The next couple of slides step you through identifying what will form the cation, which is the metal, and what will form the anion, which is the nonmetal. So here you are identifying the cation and the anion, and then putting them together to name the cation and the anion and generate the names that I had in the previous slide. All right, here's a learning check. Write the formulas and names for the compounds of the following ions. So pause your video, write your molecular formulas, and then the subsequent name. So you can see here we have +1 for sodium, and -1 for bromine, so we get sodium bromide. Then we have +1 for sodium and -2 for sulfur, so we need 2 sodiums, so it's sodium sulfide. Then we need 3 sodiums because there's a -3 on that nitrogen for sodium nitride. Let me just fix that 3. Then we have aluminum and bromine. You're going to need 3 bromines to balance the charge to make aluminum bromide. Here we have a +3 on the aluminum and a -2 on the sulfur, so we need 2 aluminums for +6 and 3 sulfurs for -6 to get aluminum sulfide. And finally, the charges are balanced for aluminum and nitrogen to get aluminum nitride. So here we have it typed up in table form. As we discussed in the previous video, the transition metals typically have variable charges. They can form 2 or more different cations. The exceptions to this are zinc, cadmium, and silver. Zinc, cadmium, and silver only form one type of cation. So memorize that zinc is always zinc 2+, cadmium is always cadmium 2+, and silver is always +1. When you have more than one type of cation, we will designate the charge using a Roman numeral. So let's look at the example here for copper. Copper can form both copper 1+ and copper 2+. So for copper 2+, when we are writing it down, we write copper and then 2 in parentheses using the Roman numeral 2. For copper 1+, we'll write the word copper and then put the Roman numeral 1 in parentheses. Iron forms iron 2+ and iron 3+, which is iron 2 and iron 3. Lead can form 2+ or 4+, so we have lead 2 and lead 4. And here we have chromium forming 2+ and 3+, so chromium 2 and chromium 3. Table 6.6 lists some metals that form more than one positive ion. All of these metals are found in that transition metal block. So those were the groups with the B's after them. So when we're looking to name a compound with a transition metal or to write a molecular formula for a compound that is formed with a transition metal, we're going to use the charge on the anion to balance what the charge of the transition metal will be. So if you remember back to that first video where we looked at group 1A, 2A, 3A, 5A, 6A, and 7A, you need to memorize that those groups always form certain types of charges. So let's look here at this formula. We have manganese fluoride. Okay? We know that fluorine is in group 7A. Fluorine will always form a -1 charge. So 2 times -1 is a net of -2. In order to balance that charge, manganese must be in the 2+ state. So the name will be manganese 2 fluoride. And that indicates that we have a 2+ cation for manganese. All right, so here's our periodic table. You need to memorize the charge that's always formed by group 1A, the charge that's always formed by group 2A, the charge that's formed by 3A, 5A, 6A, and 7A. And then these anions will help us determine the charge if we happen to have an ionic compound. Okay, and right now we're simply looking at the binary compounds where you have a metal and a non-metal. All right, so that will help us determine the charge. You can also memorize that silver is always silver plus, zinc is always zinc 2+, and cadmium is always cadmium 2+. So let's name the compound that has the formula FeCl2. Pause your video. So we know chlorine is in group 7A and will always form the Cl- anion. So Cl-, so that's a -1. There's 2 of them, so we have a net -2. So that iron needs to be in the +2 state. So in order to name this, it will be iron 2 chloride. So this just summarizes in table form what I just wrote down for you, that we have iron, we need to determine the charge. To balance this to balance this -2, we need +2, so it's iron 2 plus. So that when we write the name, we have iron 2, and we have iron 2 chloride. Next, we have to name the following compound, MnO2. So pause your video and write down the name for this compound. Okay, so oxygen is in group 6A. It will always form a 2- anion. So that we have 2 of them, so 2- times 2 equals a net of -4. So we need a charge of +4, so this will be manganese 4 oxide. Again, this table is just summarizing what I wrote down. Manganese 4 oxide is the name of the compound. Now we're going to work on writing a formula from the name of an ionic compound. So the formula for an ionic compound is written from the first part that describes the metal, and the second part describes the nonmetal. And you're going to add the subscripts to balance the charge. We have to write the formula for tin 2 chloride. I do not expect you to have the periodic table memorized. You will be provided a periodic table that has the symbol and the name. So the symbol for tin is Sn, and because there's a 2 here, we know that the charge is 2 plus. We have chloride. We know that chlorine is in group 7A. It always forms a -1 anion. So now when we write the formula, we have to balance the charge, so it would be SnCl2. So this table is just summarizing what I wrote down. And so your formula with the balanced charges will be SnCl2. So here's another learning check. You have the following names. You need to write the appropriate chemical formula. Pause your video and please do so. So it says nickel 2 sulfide, so that means that you have a 2 plus nickel. We know that sulfide is always S2-. It's one of those that you need to memorize in group 6A. So that we have NiS. Zinc is a transition metal that only forms zinc 2 plus. That's one of those that you can memorize. We know chloride is always Cl-, so it's zinc Cl2. Here we're saying that we have iron 3, so that means it's iron 3 plus. Oxide is always O2-, so it's Fe2O3 to balance the charges. So here it is just summarizing what I wrote down, where you form nickel 2 plus, zinc is zinc 2 plus, and iron 3 is Fe3 plus. And then to balance the charges, you just need 1 nickel and 1 sulfur. You need 2 irons per 3 oxygens, and you need 1 zinc per 2 chlorides. And you can see here, NiS, ZnCl2, and Fe2O3. So this concludes our discussion on how to name compounds from a chemical formula and how to use a name to write a chemical formula.